Hello, and welcome to this presentation, Getting Started with the CMA180 Two-Tone Testing. In this presentation, we'll explain how to both generate and analyze two-tone or fire-out calling using a Rohde Schwarz CMA180 radio test set. This presentation assumes a basic understanding of two-tone or fire-tone-out calling. If you're not familiar with this topic, or if you'd like a brief review, you might want to watch the presentation Understanding Two-Tone Calling before beginning this presentation. Two-tone testing on the CMA180 falls into two different categories. The first is generating two-tone sequences, that is, modulating these tones onto a transmitted RF carrier. The second is analyzing two-tone sequences from a demodulated RF carrier. In this presentation, we'll explain and provide step-by-step examples for both generation and analysis of two-tone sequences. So let's begin by showing how to insert a two-tone sequence onto a transmitted RF carrier. The generator is started by going to the global toolbar and then selecting RX under the Analog tab. RF and tone generation parameters are then accessed via the Generator tab. This is the main generator configuration screen. At the top left are the RF settings, and to the right of these are the connector and output settings. At the bottom are the settings for audio frequency or tone generation, and the Start-Stop button in the upper right is used to enable and disable signal generation. Let's now go through each of these areas step by step, starting with the RF and connector settings. Under RF settings on the left side of the screen, the frequency, level, and modulation type or mode can be configured. In two-way radios that use two-tone signaling, the mode is usually FM. Note too that if FM is chosen, the deviation must also be specified. On the right side of the screen, the output RF connector, either RF COM or RF out, can be chosen. The amount of external attenuation in the signal path, for example due to cables, etc., can also be specified. Below the RF settings are the AF settings. If mode is set to free dialing, then the carrier is unmodulated except when the tones are manually sent or dialed. Alternatively, the mode can be set so that various types of audio modulation are applied to the carrier. For example, here a 1000 Hz tone is transmitted continuously and is only interrupted when tones are being sent. In either case, the small gear icon can be used to access the free dialing tone settings, and this is what we'll look at next. The free dial tone settings dialog is used to define which pairs of tones are sent. Tones or digits are defined as a sequence, and in the case of two-tone testing, this sequence will be 2 tones long. The tone frequencies are defined in the bottom right side of the dialog. Here we define the two tones, A and B, as 688.3 Hz and 1153.4 Hz. The duration and spacing of the tones are the same by default, but can be set individually. In this example, we want our first tone to be 1 second long and our second tone to be 2 seconds long, and these are configured under individual length. We can also specify a pause, here 20 milliseconds, between the digits as well. Our two-tone sequence is transmitted by clicking on the Dial button. At this point, the configured tones will be modulated onto the carrier. In our example, the first or A tone was 688.3 Hz for 1 second, and the second or B tone was 1153.4 Hz for 2 seconds, with a 20 millisecond pause between them. The entire two-tone sequence will sound like this. This sequence will be modulated onto the RF carrier each time the dial button is pressed. Now let's go step by step through how to analyze received two-tone signals from a demodulated RF carrier. Tone analysis is started by going to the global toolbar and then selecting TX under the Analog tab. Analysis is configured from the Analyzer tab in the main TX GUI, and tone analysis parameters are accessed from the Dialing tab at the bottom of the Analyzer GUI. This is the Dialing tab under the main Analyzer screen. In the top left are settings for frequency, expected power, and modulation type, as well as the mode selection. For two-tone signaling, this should be set to free dialing, and tone type should be set to single tones. In the pane to the right, the measurement mode, single shot or continuous, can be selected, along with the number of measurements. Below this is the results pane. We'll go into more detail on this shortly. The input connector, RF in or RF COM, can also be specified, and the stop-start button in the upper right is used to begin and end the measurements. Clicking the settings icon next to mode brings up the dialing configuration dialog. For two-tone testing, we need to set the tone type to single tones and the sequence length to 2. Below this, the valid tones and nominal frequency of each tone are displayed. In order to analyze tones, we need to enter the nominal or expected frequencies of the two tones in the received sequence. Here we've entered 688.3 and 1153.4 Hz as tones A and B. Another important parameter is dialing with PTT release. Enabling this checkbox causes the CMA to continue to evaluate dialed tones, even if the carrier briefly drops, that is, if PTT is released. Once the measurement is running, the results pane will show each valid received tone. The table shows the received digits, here A or B, the deviation of each audio tone from its nominal frequency, as well as the duration of and the delay between the two tones. This table will continue to be populated as long as the measurement is running and valid tones are being received. Let's end with a brief summary. The Rohde Schwarz CMA180 radio test set can both generate and analyze the two-tone sequences commonly used in public safety applications. In this presentation, we showed how to do this with tones modulated onto an RF carrier. On the CMA180, the tone frequencies and durations are freely configurable by the user. Note that generation and analysis of tones on RF carriers requires first defining the frequency, power, and modulation type of the RF carrier. Analysis of received tones provides the digits corresponding to the tones, as well as the frequencies, deviation, and timings of these tones. This concludes our presentation, getting started with the CMA180 two-tone testing. If you'd like to learn more about other types of tone testing, selective calling, radio test, or the CMA180 radio test set, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.